Hi, hello. Uh, what we're going to do today is we're going to do a review of basic algebra for, let's take these silly headphones off. But basic algebra for differential equations. And the reason we're going to do that is, well, there's many reasons. Well, uh, one of the first types of differential equations we will solve, you'll find out that the solving the differential equation boils down to solving a quadratic algebra equation. And the second is when we get to Laplace transforms, one of the things Laplace transforms does is it turns, I'm speaking informally here, but it turns calculus operations into algebraic ones. So we're going to have to do a little bit of review of algebra first. So let's get started. And here we go. Get rid of this. All right, quadratic equations. Now, in our differential equations course, let's see. Complex solutions matter. They give us information. So we will be doing I will be showing you how to solve a quadratic and get either real or complex solutions here. So let's start off with a quadratic here. One that I picked this one out. I'm using the variable m, and let's say we wish to solve this. Now, my recommendation is that you learn the quadratic formula. And the quadratic formula says that if you have something like this, so if you have a quadratic equation like this, and assuming that a is not 0, because if a is 0, then we have bx plus c, which is a line equation. It's technically not linear, but it's called linear in courses. But this is a quadratic if a is not 0. Then solutions are, and it's good to know the quadratic formula, they're given by x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Now note, I'll put this in a different color here. B squared minus 4ac is called the discriminant. Because this discriminates between the types of solutions you have. And I know your algebra teachers have taught you this, but it's worth going over. If b squared minus 4ac is positive, we have two real solutions. And in differential equations, that's going to mean something, having two real solutions. 2, if b squared minus 4ac is equal to 0, you have one real repeated solution. And again, that's going to mean something to us. This right here is going to be, when we get to systems, this is going to be known as the overdamped case. This will be known as a critically damped case. You don't have to write that down now because we'll get to that later. And if we have b squared minus 4ac less than 0, we have complex conjugates. Or sometimes called underdamped solution, underdamped situation. Now, that's a quadratic formula. Now, it's a worthwhile exercise to see how that's obtained, because we're going to be using that, and what we go over here will be useful information when we go through the rest of our course. So I'm not just doing this for entertainment value. So let's just go ahead and take a look at that quadratic. So let's assume that a is not 0. Assuming that a is not 0, and we have ax squared plus bx plus c equal to 0. If we divide through by a, and you can do that because a is not 0. Now, and I'm doing this for this particular technique here, we can do what's known as complete the square. And the way you do that is you take this thing here and divide it by 2 and square it. So you write x squared plus b over a x plus b over 2a, that's division by 2, and you square it. But because we added this, we have to subtract it just to not change anything. All right? Now, the reason that works, or the reason that gets you anything, is this part right here, by design, is now a perfect square. So this is x. I keep forgetting to write my equal signs here. This is x plus b over 2a quantity squared. That's what all this is. So now we have a square plus a number equals 0, and we can now solve that directly by moving this number here to the other side. But when we do that, we have to change the sign. Right? Now, in order to make the solution look a little better, let's square this out here. So this is going to be squared over 4a squared minus c over a. And then if you're helping your niece or your nephew with their high school algebra, you'll tell them, you need a common denominator here. So you need to multiply this by 4 and a. So you do that to get a common denominator. And on this side, once you do that, we have the b squared minus 4ac, that should look familiar, over 4a squared, that should look almost familiar, and that's equal to this. And now we take square roots of both sides and keep in mind we want both solutions. So we know that x plus b over 2a is now going to be plus or minus the square root of this. But we can now do a couple of things at once. X is now equal to minus b over 2a plus or minus, we now got in the numerator, b squared minus 4ac. There's your discriminant. If you take the square root of 4, you get 2. Square root of a squared is technically the absolute value of a, but that's the plus or minus takes care of that. Or you get x is equal to minus b plus or minus the square root of squared minus 4ac over 2a, as we needed to. So what we see right here is that the quadratic formula, and we're going to do this problem here. The quadratic formula is just completing the square formalized. Now let's solve this problem. So this is m squared plus 5m plus 13. This is an example. Well, plugging into the quadratic formula, m is going to be equal to minus 5 plus or minus the square root of b squared minus 4 times a, which is 1 in this case, times c, which is 13, over 2 times a, which is 1. So what we get here, minus 5 plus or minus, now 4 times 13, 13 is 52, right? So 25 minus 52 is equal to minus 27, okay? Right, so it's plus or minus the square root of minus 27 over 2, which will be minus 5 over 2 plus or minus the square root of 27. And I know that can be uh, simplified some. So 27 is 9 times 3. So what we get out of this, so the square root of 27 is going to be the square root of 9, which is 3 times root 3. So m is minus 5 halves plus or minus 3 root 3 over 2i. Now, if you noticed, instead of leaving this as one fraction, I broke this down into what's known as the real part and the imaginary part. And that's on purpose. That's going to give us information down the road. And to just give you a sneak peek, if we use this as a solution, what we call a underdamped harmonic oscillator, this basically, the minus 5 halves gives a measure of how fast the oscillations die out in amplitude. This part here gives us a measure of how what the period of the oscillations are. But that's for something down the road. But that's how you solve a quadratic, and thanks for watching.